Okay, so this first question that you've asked me from the homework is a very important question. I like it a lot. Be prepared to answer it on a quiz. Do we have any anti-differentiation rules about this?
No.
No, we do not. So you have to use your trig rules to try to rewrite this as something that we can take the antiderivative of.
Yeah, sine squared, cosine squared.
Nope.
Isn't it 1 minus cosine?
What's what sine squared?
That would be, if it were gonna be sine squared, it would have had to have been 1 minus cosine squared,
Oh,
right?
yeah.
Isn't it?
1 over cosine squared plus cosine squared over cosine squared.
You just rewrote it.
Yeah, just rewrote it. What is 1 over cosine squared?
Oh, it's secant
So really this is secant squared
plus 1.
plus 1. Can we take the antiderivative of secant squared?
Yeah.
Yes. Tangent of theta. What's the antiderivative of 1?
Or
Theta. And we want to evaluate this at pi over 4 and at 0. So that means we're going to have to know what is tangent pi over 4.
1.
That is 1, you're correct. And I'm also going to have to know tangent of 0. So this part is 1 plus pi over 4. Tangent of 0 is 0. So then that just becomes minus 0, which just gives us 1 plus pi over 4. Can anybody verify that that's the correct answer from the answer key? Yes? Thank you.
Wait, what's on there?
Yes,
Can
sir.
you convert the 1 into 4 over 4 and then just have?
Sure. Oh, wait a minute. Convert that 1.
Actually, never mind.
No.
It's just.
Yeah, that doesn't help. Because this is not really a fraction answer. It's just 1. So if you wanted to rewrite your answer as 4 plus pi over 4, that's fine. That's the same thing.
And then you might as well just write it.
You might as well just write it the other way. So. Okay, so for 35, I'm gonna go ahead and change these roots over to exponent, fractional exponents, so that it makes it a little bit easier now to divide this up. When you want to divide this up into 2 values to integrate. So this would be the same thing as the integral from 1 to 64 of, what would this be?
Negative
X.
X to the negative 1/2, good, plus,
X to the negative 1/6.
yes, I get x to the negative 1/6. And so now when you integrate, you're going to get x to the 1/2 divided by 1/2, which really becomes
2
times 2, plus, and then x to the 5/6 times 6/5, evaluated at 64 and at 1.
So 16.
So this would be 2 square root of 64, yeah, which is 16, you're right. Plus 6/5, now this is gonna be the 6th root of 64, which is, what?
Yeah.
You should know that without a calculator.
2.
2,
Okay.
and then 2 to the 5th
Is 30.
would be 32.
Yeah.
So I got all of that minus, now when I input 1, won't that just give me 2 plus 6/5? Okay, so this is really 16. And for some reason I like to subtract my whole numbers first, that's just easier for me to do without a calculator. 16 subtract 2 would have been 14. This is 192 over 5. Subtract 6 over 5 would be, would that be 186 over 5? This would go 37 and 1/5. Check my math on that because I just did that in my head very quickly.
Yes.
37 and 1/5
Yeah.
plus 14
would be 51, or, yeah, 51.
51 and 1/5. Can anybody verify if that's right? Did it leave it as like, yes,
Kept just the fraction.
256 over 5? Same thing? Okay, and then we'll look at number 37. So I would start out by changing those roots over to fractional exponents. And now you just integrate. What will this become? X to the
Maybe 5.
9 fourths.
4 ninths.
Good. And this one would be X to the
9
9
fifths.
fifths.
And then
5 ninths, evaluated at 1 and at 0. I like that it's evaluated at 1 and at 0.
Yeah,
It's a whole lot easier to work with, so I end up with
4 ninths.
4
plus 5
ninths plus 5 ninths minus 0, and that just turns into 1.
Okay.
Will you stop our recording, please?